All right. Hello. Good morning. Um, yeah, I'm having so much fun with these streams, and I'm also trying to improve the setup. So I thought I would just do a stream. Like the oldest is downstairs watching TV, eating like Saturday candy. Um, Oscar, the smallest one, is down in the basement sleeping, and my partner is outside enjoying the sun, and I'm inside enjoying the stream. Now, one thing that's bugging me with I'm using StreamYard, and now I'm actually streaming through the official CodeSandbox account, even though it's to my YouTube channel. It's through the CodeSandbox StreamYard account, which has a pro account. So we should have a really good, like it should be 1080p, and yeah, and the audio should be good as well. One thing that's bothering me is that my face is down left. So when we move into coding, I'm kind of in the way. I'm a little bit unsure how. Maybe we can even make it a little bit bigger. I don't know how to move my face to the right here, which is really annoying. I wonder if I can do something about layouts. Crop solo layout. What's that? Crop. Yeah, I don't know. Yeah, I wish I could like move my face to the right. That's super annoying. Like, because I think it becomes a little bit impersonal if I don't show my face, and it's like if I do this, it's kind of, well, that's not good. This is not good either, because it should be about the code, but then, oh my god, this is so annoying. Yeah. Yeah, we're not going to spend the stream figuring that out, but there has to be a way to do this. No, that moved back to picture in picture. Yeah, I have to send them an email and ask why the hell I can't put my face on the right side. But at least I have something to show you. I've been iterating on. Let's see. Oh, I can't let this go. We have to kind of move the. How should we do this? Let's move the settings. What's the setting for moving the Explorer? How do I do this? Is it activity bar left? Oh, there we go. Okay, I guess we can do this for now. So my face is kind of down there, and then at least we have, and I'll just keep it open. Yeah, I think this is best. Okay, cool. And now we can make it even bigger like that. And this is nice. Okay, let's try this setup. See how that works. So what I've been exploring, let me show it to you first. I've been like, there is this concept in Rust called structs, and it's kind of like states. The thing is that you do not only enter like, so the way you would define them, something like, something like this. So you would say like loading, and then that's like a struct, something like this. This is like pseudo syntax. Or maybe loaded would be better. Loading, okay. Loading, and then you would say, for example, you would have a loaded function, and that would like move you into data. Let's say, call it data success, and then that would move you into like loaded, something like that. So the point is that you you're able to express functions with your explicit states that transitions you to other states. This doesn't work with React. It's impossible to do this in a nice way, because you have to, like, if you were to express a function in your state object, you can't dispatch that. So you would have to like override the functions and pass in the dispatcher and stuff like that, and that becomes quite icky. But I started to think about us actually being able to do something similar. So the way it works now is that first I define actions, and I'm using action creators instead of typing the actions. And then I have this pick return types helper that just allows me to easily create the action type by just pointing to these actions. I have the same for commands I want to do. It's like command creators. And I do the same thing here. And I actually do the same for the states as well. They are state creators. And I create the state type by using pick return types. And then just for convenience sake, I destructure the explicit states because it's just nice to be able to express them directly like this. Now, the interesting thing though is what I thought about is, what if we didn't allow you to put functions in your state that transitions you to other state directly? But what if it was just these action creators? So what you can see here is that when we are not loaded, I'm actually exposing the fetch to do's action creator. And when I'm loaded, I'm exposing the add to do action creator. So it's only when we're not loaded that it's actually valid to do fetch to do's. There's no reason to do it in any of the other states. And the same is for add to do. There's no reason to do add to do in any other states. So we're kind of bringing more information out to the consumer on what kinds of actions can you do in the specific states. But they are just action creators, which means that when we move to the app and we consume this, as you can see, we have the to-dos reducer here. And if we look down at where we consume the state, when it's not loaded, I now have the fetch to do's action creator, and I can dispatch that. So I still have to do the dispatch, but I don't have to like create this object and use the type and stuff like that. I actually have what action creators are available to me in the not loaded state. And the same goes for loaded. What action creators are available to me when I'm loaded? And I think that's really nice. It kind of balances this thing of we can't, like, we do want a generic dispatcher that can receive actions and events no matter what state you're in. Like, that's the whole point of a state machine. But we can help the user understand, like the consumer understand, what actions are actually expected. Are expected in the different states. So that's something, and just how we write this out, everything is like behind an object, and you easily create the types for them, and you create the constraints by them being these creators. It's I really like this. One thing I thought we could do before I update this version is that since we have these action creators, we're actually giving information now on the state that certain actions should be handled. So here I'm saying that fetch to do's is something that you can do in the not loaded state, but you don't have to put it here right now in terms of typing. So I thought that could be a fun thing to tackle first, is how can we actually make this yell at us if we don't handle the action? So where do we need to go then? That's one thing. And then the other thing is in the debugger, we're going to do something there. But let's first try to solve that issue. So we have this thing called T transitions or T transition. Yes, so I guess it's T transitions that needs to deal with this. And how will we do this? So this is actually, this is interesting. So these are optional, all the actions for each state. Yeah, I think we actually have to solve it here. So I think by default, we just make every one of them optional like this. And then what we're going to do is we're going to iterate through the state. So the way we do that is u in key of, yeah. Yeah, because this is the extended state. Ah, shit. How are we going to do this? Oh. We want to check if we have a key that's an action creator. So I guess what we could do, fucking neighbor is doing some stuff. We could do T state actions. We do exactly the same as we do above, but we check if it actually, yeah, this is interesting. So what we're going to see if it extends params any, does it actually T action? Is it an action creator? And this should actually give us all the keys that is an action creator. Oh, but this is for each state. We want for the specific state. Yeah, I guess it. Yeah, it does work because we can narrow down the state to the specific state, or we can do it for all the states. It doesn't matter. So we can try this first. So it will be T U in T state actions, and this will be S and state SS. This should give us all the keys, all the actions. Yeah, all the keys that are action creators in that specific state. And what we want to do, what did we want to do? We wanted to not make it optional. This is interesting. Yeah, because the thing is, like, if you see in here, in here, I just happen to name the action the same. I wouldn't necessarily have to do that. So we actually have to check the return type. Yeah, so we would actually have, this is interesting. I think we should go and do this in the TypeScript playground because this is getting quite complex. T state, where did I create that? Where are you? T state actions. Let's go to the playground. Go to playground, TypeScript. playground. And let's look at this. Oh, this is so annoying. My face is. Why the hell don't they have a right side face? That's so annoying. Yeah. What's it? Edit thing. Oh, okay. I'm not going to bother. So we have our T state actions. And let's create the action as well, which has a type. Okay, so let's just create like a foo, and let's make sure it's a union so that we handle that case as well. And then we'll do an action creator here. So switch, something like that. And it would return type switch. Now we have something that we can test. So as T state actions state. So this should give us switch. Nice, it does. So that's working. But the point is now it gives me the key. So if I do this, it should give me switch. Yeah. So that needs to change. So we would need to infer the actual action here. I'm gonna do A. Yeah. And then this would actually become a type. Yeah. Oh yeah, it doesn't know. Oh yeah, we have to, yeah. And then we don't know that it's an action right here. So we have to, if A extends the action, then we can say A type, or we will never. Oh, A type. Now regardless of the name here, we should now get the correct type, which is nice. That's what we want. And then we want to make sure that we can combine this. Okay, let's bring this back and see if we're ready to actually do something with this now. What did I do? Yeah. So now we have the correct keys, and this should basically just be the same. But here we would have, yeah, you. Oh, does this work? Where's the app? Oh, sorry, to do's. What do you know? It actually worked. So property is not the same. Well, property fetch to do's is missing. Fantastic. We did it. That's awesome. Okay, so that's interesting. Now we actually, when we say that we point to an action creator, we have to define it within the state to handle that action. That's a nice safety. And then we have, and let's see, yarn. Oh, I am running it. Let's see. Here. So we're fetching the to-dos, but as you can see in, for example, the loaded state, we have like the action creators comes in as as this thing. So what I want to do is in the dev tools. What are you complaining about? Yeah, whatever. I want to make sure that this is the inspector value component. So if it's a type of, here we go. If type of value is function, you can give it like what did I call it? Was it string value? Boolean number? No. other value. Oh, we can. Yeah, I can't remember the colors here because I have string value. No, it's the other value. Other value. I think that's like purple. And what we're going to do is we could just write action, but we could also extract. That would be kind of cool. Well, it does state add to do. Like we could extract like add to do. No, but I think we're going to like keep using these things. So let's call it action and just see what happens. We don't need this stuff. Yeah. Oh, that color wasn't very bright, was it? What do we... Purple. I want to make that brighter. Is there like a... I think I stole these colors from like Tailwind CSS. Oh, colors. Didn't they have like colors here somewhere? Customization colors. There we go. Yeah, so let's steal those colors. So we have blue is blue. And blue 500, that's a nice one. Sky, or blue, let's just use blue. Stealing that one. So this inspector is actually something I built manually. Related to, I think it was all the way back to the Cerebral DevTools, and then I reused it for the Overmind DevTools. And now I'm reusing it for the React States DevTools. And then we have yellow. And then we have purple. Purple. We could even, yeah, that's a bit better. State loaded and to do action. Yeah. And then, yes, cool. Yeah, let's not mess around more with that. So I think we're just going to publish this, and then we're going to continue refactoring something I worked on. Yarn. Make this right. Typing. I'm not in the mood. Oh, not in the mood to. Yeah, and let's change the package version here. Let's just do something like this. Yarn build and yarn pm publish tag next. And then I am to use my go. Please don't use that code within 18 seconds. Yeah, the DevTools is pretty awesome, and this is like in its infancy. Oh yeah, you mean the it's Cerebral and Overmind DevTools. Yeah, they're pretty. I'm pretty happy about how they turned out. It's kind of cool. Like even just looking at Cerebral, like all the information you get about execution, it's like it's almost like looking at the call stack in Chrome DevTools, but it's the call stack of your actual application code and not the low-level JavaScript. which is pretty awesome. And with the like forking and stuff like that, it's pretty cool. But yeah, this dev tool is very much in its infancy, and I think we can do a lot of cool stuff with it. But that's something to discover. Okay, cool. So let's move to not GitHub. Oh, there we are. Sandbox. And I've been working on refactoring the family Scrum. So let's open this in VS Code. Yes, I trust CodeSandbox. And I've already done a few changes here. Maybe it should be a little bit bigger. Yeah, first we have to. Oh my god! On a Saturday, why do they have to? That's so annoying. Okay. So this project is using the latest pattern. And what we're going to do is that we're going to just update this with our latest discoveries. So this is the dashboard. That's quite heavy. Yeah, and this here you kind of get insight into what does this pattern of creators achieve. So here we have like a dashboard for this family Scrum app, which has some data, and it has some substates. Specifically here, which view, what page are we looking at? And what we can do now is we can do pick return types and type of view states, so we can simplify that. And now we're, instead of having the action type, we're going to create the actions. So bear with me here. As const, and this takes a view state and adds that, and then we have pop view, and that has a type. As const, and the reason I'm doing as const here is because this type actually matters. It's not just a string; it's a very specific string. And this also took a view state, type as const view, and then grocery input changed, and this has an input of a string, and it has a type as const with the input, and then we have add grocery, which has a name, and it has a type as const and with the name. So now we actually have all the typing inferred with the constraints of this being action creators. Pick return types, type of actions. So now it should be happy. And then we're going to do the thing I did, moving the states into in here, and then we'll rather destructure them again. It's just so that you kind of have these variables containing the different parts. Let's do that quickly. This, and this, and this. And then we have the error. And there we go. And now we can, it's my daughter. Like I bought this Apple iPod Max, is that the name of it? And it's so expensive. And the person who uses it the most in this family is our daughter. But it was a really good buy because they are really awesome. Like when I watch movies in the evening, I kind of get into my own world, even though like my partner is running around doing her stuff. But the good thing, it has noise canceling. So with Oscar, who's like 1 year old, screaming and messing up our daughter's children shows, that doesn't happen, which is nice. Okay, cool. So now we have the state creators here, and everything's inferred. And we destructure them so that we can use them directly. And we should also export these, because you might want to, like, you want to set the initial state to something. Blah blah blah. Yeah, so the way this works is I have a few. I should probably move this to a folder, because it does have like some utilities and stuff like that. Yeah, maybe we should do that. Anyways, I just want to show you how it works. So these are just some utilities for updating the state. What the hell? And here we have the actual state machine. So this actually takes some events from the environment. So when we're awaiting authentication, we're moving into like a loading state or a requiring authentication state. And then we move into the loading state. And then this actually does, I'm not like perfectly happy with this, but it kind of shows you that before we can move into the loaded state, we need all these events to trigger, and they trigger at different points in time because they are like separate requests. So what I do is I just evaluate if I now have all the data, and as soon as this evaluated loaded state has all the data, it moves into the loaded state, or it just continues in the loading state until it gets all the events. So it kind of shows you how you can do like more declarative complex asynchronous stuff. Like with RxJS, for example, you could just funnel all the events, and you can use like an operator to make sure you had everything. But this shows you that same concept. God damn it! Why is it moving over to? It shows it in a reducer. And then when we're loaded, we can still get events with updated data. So that's what you see here. And then we have like the push view, replace view, pop view stuff. So what we're going to do now, we're going to express in these states what actions can be performed. And as we can see here, it's really just, most of it is events from the environment, which is not something which is not tied to the consumer. This is just coming from the outside. But what's tied to the consumer, like what does the actual application trigger as actions, is push view, replace view, and pop view. So let's add them to the loaded state. And the only thing we really need to do is, what was it? Push view, actions, push view. We have replace view, actions, replace view, and we have view, actions, view. So now if I were to, like, we're kind of refactoring here, but if I did this from scratch, when I actually got to the place where we define the transitions, I would actually get help with this, because now this should error. Exactly. That's super nice. Cool. Yeah, and here you can see, like, instead of having this concept of features and context providers and stuff like that, this is now just a hook tied to the piece of UI that actually consumes that hook, which is a lot better. One thing that's still a context provider is the session, and that's just because it makes sense. So it's not like context providers are bad, it's just that use them when they're necessary. Yes. So now let's look at the dashboard and see, and just refactor a little bit, because I changed now to data instead. So we have data to-dos, data. Plan next week. Oh, is it view? I changed that? No. And next week. Oh, this is interesting. Do we have a bug here? So I'm matching on the view. And if it's plan next week. Yeah, something weird going on here. There's definitely something wrong going on here. Yeah. Let's bring in these action creators. We're going to figure out why the hell this is failing. Because when I hover here, it's correct. But when I hover here, it's actually wrong. So why the hell does that happen? Oh, I think maybe I know why. Yes. Okay, so this is the only thing I find to be problem. It's that you have to remember as const. If you don't do that, you get these weird issues. You saw it actually looked correct, but it actually failed. And that's because one of these unions doesn't have a constant on its state, so it's evaluated as a string. So that's actually not ideal. Maybe we could have like a helper for that. I don't know, because I when it happens, I quickly pick it up, and so I'm not sure. Yeah, we'll have to explore that. Anyways, so what we're going to do now is we're going to dispatch you. We're going to, yeah, and then we have, let's see, we have the view states here. Do we export them? No. Can actually export. Oh, this is it. Yeah, so that's also interesting. So what I could do here, now I'm exporting like push view, but it doesn't, I could be more explicit. So it would be like open dashboard, open groceries shopping, and so on. But let's try to do this instead. So this is going to edit to do. So we're going to dispatch push view. Then we have to give it a view. So we would have to point to like view states, edit to do, and give it the ID. Which is perfectly fine. I think. Well, I guess I would prefer having it as specific action creators. But let's not do that now. We'll say that this is perfectly fine. So we're going to push view, view states, edit to do. ID. And then we have dispatch replace view, view states, plan next week, and the sub view is dinners. And then we have another replace view, which is to-dos. And then we have dispatch pop view. And this is beta dinners, and this is dispatch push view. states, edit dinner ID. And now we have, yeah, so what could also do is like, could export functions that that kind of does this under the hood. But yeah, it doesn't matter. We just, like, the thing I like is to have some core fundamentals that allows you to create your own patterns. So in this case, you don't have to do any of this. You could import the action creators from the hook if you wanted to do that and use them directly like that, or you can add them to the explicit states, which increases discoverability. But it's not like we're not dictating how to do things. Push view, view states, edit dinner. We're happy about that. Data dinners, data to dos. Oh, dispatch pop view. Maybe this is a little bit boring. I can rather do this later, really. It was just to see that it actually works, because we do have another TypeScript issue, actually. Let me just finish. Dispatch, push view. This is nice. What I do really like about this this pattern is how like everything is just these tiny functions constraining something and creating like a type. So you have like, here I have some substates, this being like the current view. I have the actions that are expressed exactly the same. If I had commands here, they would be expressed the same way. The states are expressed the same way. It's all the same thing. They just have different functions. Yeah, it's very functional. I think that's where like when you type things and you use objects, it becomes like arguably less readable. Just like looking at this, it's very specific, right? You can't be more specific than this. We're moving into loading. We're moving into requiring authentication. If you do like an object and you have a state property and you have to read the state property, it's not as explicit. So every kind of piece of information becomes more concise. It's not like stretched over multiple lines, which I guess people argue is the good thing about functional code. And I guess this just makes it more functional. It definitely does. Yeah, I think this is pretty awesome. What I also discovered, let's see if I can find that, edit dinner. What also happens here is that, let's see if I can find that. I did have some pretty complex changes. No, it was not here. Maybe it was here. Because we have this match function, which is primarily to be used with to be used in UI. Like, it's not intended to be that way, but it kind of happened. But when we have these explicit state creators, you start expressing your code like this. So when you're editing and you receive the date toggled action, we're going to move, we're going to keep editing, but we're going to update the date. Because each part of the UI, you can toggle on and off if you're adding a date or you're adding time or you're adding a checklist. So this is like toggling that view. And instead of like doing these ternary expressions or whatever they're called, you actually match on them because they're like substates. So the date is either active or it's inactive. And that is expressed as a substate. And what you do is that you start using this match with your state changes as well. So in this case, and this is like beautiful. Action, let's keep editing on the date. Let's match on it to see what state we're in, and then we'll transition to a different state. So that's the beautiful thing about match. It doesn't matter what the return value is. It can be related to creating a new state. It can be related to rendering different pieces of UI. It can be producing different styles for an element. It doesn't matter. It just ties these states to a specific return value. And it's automatically inferred and everything. So if I were to create some invalid value here, it would yell at me. So everything's like super properly typed here. And you kind of see how, I kind of point back to this, how functional it becomes. It's really nice. And here you have like some super complex, like this hook either takes an existing to do, which means you're editing an existing to do, or or you create a new to do. So if you have an existing to do, it produces like it needs to produce the correct view based on the information from the to do. So here, of course, it has a description, and then if it has a checklist, then we create an active checklist state where the selector here is just to sort the items correctly and then map to a simpler structure. Like it only needs the title and the ID. And then, as you can see in a more simple example here, if we have a to-do date, let's put the UI in an active state with that date, or it's inactive. So it's, yeah, I really, really like this. It becomes super, super expressive. But we actually have a problem here. So instead of looking at me just refactoring a bunch of code, let's check that problem I found. So the problem was, where was it? Is it in grocery shopping? Yes, it's here. So the problem is that when we're in a filtered state, so this isn't refactored yet, but when we're in a filtered state, you can add a grocery and you can shop a grocery. And you do that with a command, because this is like an effect that we want to guard. You should only be able to add a grocery and you should only be able to talk to Firebase to add or shop when you're in the filtered state. So instead of the UI telling Firebase to add a grocery and then tell the reducer to update, we tell the reducer to update. We tell the reducer that we want to add a grocery. And then given that we're in the correct state, we actually return a command to execute that side effect. That's the point. And then, the problem here is that we have two different commands that can be run. And what happens now is that in here, it's not able to infer anymore. It kind of, let's do this. It infers both of them. So we have a problem with the way use command effect types this. It doesn't type to the specific one. We need to fix that. Maybe it's simple. I don't know. So what we do Let's see. Okay, so here we have the actual command that's supposed to be typed. And what's happening here is that we are looking at the state to see if it extends the so this is the thing with this TypeScript, is that even though we already know here that we kind of have a match, because the CC is part of S, we kind of have to reevaluate that, which is what we do here. We reevaluate that, yes, indeed, we do have the CC property in state, and then we go in and we grab that CC property. Yeah, so this is the thing. And the reason we exclude undefined here is because that command might be optional, and that wreaks havoc with our typing. So that's why we exclude undefined. But this thing, I think we have to make sure that this actually extends. Or maybe we can just do something like this. Now we're just saying that this property, that's now like a generic thing, meaning that it picks up any of the commands. Now we're saying that the command has to be the one we chose as an argument. Like, oh my God. You have no idea how much TypeScript I've done trying to understand this. It didn't work. Or and command T state command state. Yeah. That didn't work. Yeah, that's what I wonder. Why is it seems that CC? Oh, yeah, that's what I don't quite understand. Like what we're doing now, we're extending all the commands. Oh, sorry. I'm still not recovered from my cold. Oh, I'm just going to blow my nose. 2 seconds. I forget how I'm a streamer. Nej, eller... Men jeg kan jo være ferdig snart. Ja, kan du ikke sette kjellerdøra på gløtt, da? Okay. All right. Let's see if we can solve this. So, yeah, and again, like the commands thing is the one thing I haven't like concluded on yet. I think it's like the pattern I discovered that I really like is maybe we can go to one of them that's more refactored. Yeah. So for example, here we have this exit. Oh no, I'm actually not doing it. Maybe we can refactor this. So the pattern I really like is that what we do is we should, when we're editing, we should be able to say that we want to exit from editing. And I just do exit equals false, which is just a Boolean, which doesn't really make sense. So what we're rather going to do is that we're going to say that you should be able to, well, there's a single command here. Okay, let's just do it like this. So you should be able to pass exit if you want to. And this exit, sorry, we have to type it. So this exit is the return type. This is will be better as well when it's properly refactored. But the point is now we have an exit here. And this is optional. Oh yeah, yeah, this is the thing. Sorry, this might seem confusing. Let's do this somewhat how it's going to be. It's going to be like this. So, why are you complaining? Oh, yeah, sorry. Commands. So this is how, so the way this will actually look is that it, okay, let's just, sorry. So what you would have, you would do exactly the same thing. Pick return types, type of commands. So now you have the commands type, just like everything else. And then where we have the exit thingy, you would do pick command. You would pick, that's the way you would do it. So you just say, okay, I want you to be able to pass in an exit command here, potentially. And this is the type for it. And then we just add it here. So when we go down to where we actually do this now, I can call this exit, and I can say commands exit, and then it's executed. So that's very expressive as well. Just having this last object where you have optional commands that you can run, then it becomes like part of the typing. It's very explicit when you move into a state if you actually execute that command. Sometimes you want the command to run every time you move into the state, which means that you don't have to pass it from the outside. You just call it from the state creator. Where was I? What were we doing? Were we trying to fix the type still? Yeah, we were. Sorry. I'm not sure why I diverged there. Anyways, yeah, like, is this idea of these commands a good idea or not? And the one thing I, of course, don't like about them is that they become a part of the state typing. So when you consume like from the UI, you actually see those commands in the state. But again, it's informing you about what that state does. So it informs you that, okay, when I moved into this state now, you will see in the typing that it actually executed an effect. So it's very like educational, both the having the action creator in there with the state and also the command that was run. I think it's a benefit, because you get a lot of information about the state when you consume it in the UI. Anyways, yeah, you kind of get the state, you get what actions can I run, and you also get what commands were run when I moved into this state, which is, yeah, it's quite powerful. But we have to fix this typing. And the problem is that this CC gets all of them, which it should. Like it extends a union. But that's what I don't quite understand. Why? Because this is a generic. Why doesn't it? Why does it? Let's move back to the Since this is now very explicit at grocery, why does it say that it can be that one or that one? Oh, wait, we have this one. And is that because I didn't remove it yet? Oh yeah, sorry. So let's remove this again. Right. So even though I'm explicit about this thing, it still types it as. So what I want to try, just to understand better what's happening, I want to just make the command, or we can do a blah, and we just move CC in there just to see what it evaluates to. Oh, so it doesn't actually evaluate to the specific thing. It actually evaluates to this, which I found very peculiar, because we're saying extends, we're not saying equals. Extends tstate commands. That is weird. That is weird. Why? Why doesn't TypeScript understand that? Because this should be narrowed down right here. It might be because this is a callback. I think I've experienced that before. Like if we were to, again, we can do blah here instead. Same. Oh, add grocery. No, wait a minute. So there we have. Oh, sorry. Yeah, no, that won't work. Yeah. Well, yeah, what I want to do is use command effect. What does it expect to be there? Oh, can't you show me the whole thing? View problem? No. Oh, let's put it in the front. And let's see if we can make that work. So instead of does it actually evaluate? No, it evaluates to, it doesn't care about the value I insert here for some reason, which is kind of the point of a generic. But I guess this is like more of a complicated type. So why doesn't it resolve? Maybe you could argue, but this one, like, you can't do much about this one. Because you don't care about, like, this should return all possible commands, regardless of state, as a union. And it does. Like, we can see that. It actually does what it's supposed to do. Like, this typing is perfect. Like, this is exactly what it should do. But for some reason, it becomes a union. Okay, I think this needs some dark magic. Like, this should definitely not work. Yeah, because it's just proxying the type. Like, this is, now you can see how desperate I am. But what I don't understand is, what if I were to type this manually? Foo or... well, let me just do explicit add grocery or shop grocery. Yeah, exactly. You see that? So it's as if it doesn't return. Now it's correct. Now it's not a union anymore. So it's as if it seems like the thing we get back from the thing is wrong. There's something bad about this. We're going to take another look at it in the script playground. Type t command string. Okay, so let's create like a state here that has state foo or state bar, and we have two commands. We have number one, command number one, and then we have command two, and then we'll do a test where we say as t state commands state. This is the thing. It doesn't really give me much, does it? Like it just gives me this. Why does it give me that and not the evaluated? What if I do this? What do we get then? Oh, it's just t state command still. Maybe we just need a smarter way of doing this. Or maybe it's the universe telling me that these commands aren't such a good idea. Might be that. Why doesn't it actually evaluate? Why does it just give me this thing? How could I do this in a different way? Because I have to base it on the state. That's all I have, the state. So I have to go through each state because it's a union. So I have to go specifically through each state because that's the property that represents the union. And then I extend so that I can go through the specific state. That's what I'm doing here. And then I'm looking at the property of that state to see if it extends the command or undefined. Oh, this is also interesting because I don't really. Yeah, this is also wrong because I exclude undefined. I want to exclude undefined and then see if it extends t command because it might extend something else might be undefined. So that's definitely a bug. But it doesn't really help me. But maybe it's just so we don't forget, exclude. Oh shit, was that the thing? Oh, nice. Nice. That was the actual problem. Yeah, nice. Shit, we solved it. Nice. Perfect. We solved it. Nice. Cool. What do you know? What did I do? Let's just copy. Let's just copy the t-state commands. And let's shove it into the typing here. T state commands. There we go. Oh. Nice. Happy about that. Then let's just shove out a new version here. It and type fix. Yarn build and npm publish tag next. And let's see. Nice. We got that covered. Where were we? Here we were. Let's install the latest again. Yeah, I'm a little bit. I don't think it makes much sense for me to sit on the stream and just do this pattern stuff. But what we can do, which I forgot, is that we can write the documentation for this. Because then we kind of, that's a nice summary. Oh my god! You know when you have a cold and then like everything comes out, and then you get to this point where you kind of just get stuck like right here, and then you have to do this all the time. Oh, 2 seconds. Oh my god. Yes. So let's look at the API. So we have transition, we have use state effect, we have match prop, and use command effect. And then if you choose to use the environment, you can define an environment, you can create an implementation of that environment, you can provide that environment, and you can use that environment. That's beautiful. And then for testing, you can render a reducer. Yeah, it's pretty cool how it works. It makes testing super simple. And then we have pick action, pick command. That's one that's missing. And pick command allows you to point to a union of commands and pick one of them, while pick state command is actually pointing to the state type. And then yeah, yeah, exactly. So you can point to a state type, and then you can choose a command so that so for example, imagine you're writing a function and you expect the state that's passed into that function to have a certain command tied to it. And that's what pick state command does. It allows you to define an argument where you don't really care about what state it is, only that state will actually deal with a certain command. And then we have the dev tools. Okay, so what we're going to change here, yeah, and we have this I think we should put that up here. Pick return types. Pick return types. So let's make sure we actually have those. What was it? Pick command and pick return types. Let's add them. So you have pick return types. I'm not sure if it's the right term here because we're not actually choosing one. We're basically saying you're getting the return types from a record. So you could argue that it should just be return types. Just like you have return type, you could have return types. That's more correct, actually. Creates a union. Point to a record of functions and create a union. This is like super generic, and it's so fundamental. Like I can imagine this being valuable in many scenarios, completely unrelated to this. Just being able to like have a type helper or a type utility that lets you point to a record, and if that record is just a bunch of functions, you get a union of all the return types. That's like nice to have. I guess it's not so common that it should be part of TypeScript, but like it's not specific. The alternative would be yeah. So what you could do is, and this is interesting. So you could pick return type, and you could say like T state, and then type of states, for example. What that would help you do is it would actually evaluate if the return types is correct. Yeah, maybe we should do that. Yeah, so you would rather, of course, it would be the other way around. So it would be like this. So pick return types, type of states, and it needs to be this. It needs to match that state. That makes sense. Okay, let's fix that. That means that we actually do need to, and we do that. We export all the interfaces, so that's not a problem. So we have pick return types, and this just needs to be like a type. Sorry for having not being more explicit. So what we need to do, return type extends u. Then we'll return it, or we'll send never. But if you don't have the if you don't have, yeah, so this is interesting. Like what should happen? What happens now is it will just completely ignore it in the union, because when it's never here, it will not be picked up by this key of T. Maybe there's yeah, let's try this first. We'll have to kind of try to make sense of it. And then am I actually using it here? To do's? Yeah, of course I am. Type of actions, T action. Type of commands, T command. And then T state. So this is definitely the right way to do this. But what if I were to do this? What happens now? So it just doesn't, like I said, it just doesn't include the error because it's not a valid match. So you could argue that it should rather like yell at you. I'm not sure how to do that. How could we make it yell? What if I were to do like unknown? Yeah, that's nice. And if I do state, then it's okay. I think that's better, because then you at least you get. I wonder if I can do like invalid return type. Can I like code my own message? No. Oh, yeah. Well, that's interesting. Yeah, I guess that's better then. Like it's informative. Invalid. But could I even like do error? Yeah, but it doesn't really say anything. I think we should try this invalid return type. You know what we could do? This is so funny. Like, we can actually do this. It's kind of crazy. Invalid return type. Not U, but K. I think. Why is it yelling? Oh yeah. This should now state. Well, now it's called error. Let's see. State that's invalid return type. This is this is kind of cool. I never done this before. State error has invalid return type. Yeah, cool. Let's just do that, just for fun. Just for fun. Yes, so that would be pick return types. Point to a record of an encrypted union of a specific return type. Gives an error in return type. So the way you would use this, you would say const actions, for example. Do this. Do this. Do that. Type do that. And you would get type action is return, pick return type of actions, and it should be of T action. You might wonder like why is it called T action when it's actually an interface? I don't know. Maybe we should change that as well since we're here. Yeah, let's do that. I state. Or I actually think it starts no, of course it's just a name. Rename I command. Cool. So we'll need to change this. Typically used when I state, I action, or I command. Cool. Narrow to specific states, and then we had another one which was pick command. Narrows to specific command. Pick command. Narrowed commands. Pick command. Yeah, so this also makes more sense now. Actions, state, sorry, action, command, Yeah. This is actually coming together. Narrows to specific states, which has the commands. Exactly. And states. Cool. Yes. So let's refactor these examples here. So we have const actions, switch type, switch const, then type action. Oops. Type action would rather be pick, return types, type of actions, by action. Let's integrate it in pick, return types, by action. Yeah. Cool. And then we have states. It's just this. And bar. And this will be pick, return types, type of states, and this should be iState. Then, as I said, I think it's a good pattern to extract or the structure. Yeah, yeah. Okay, let's remove the error message. To me, it's also, as I said, I've never done anything like that before. Where the hell did we put it? Pick return types. Yeah, let's just call it, and then I don't have to do this stuff either. Unknown. Yeah. Yeah, exactly. As you said, it hints to you doing something wrong. Why does this have a change? Did I? Oh, it's because I, yeah, of course. I changed the type. Or I changed the name. Where were we? API. Yes. So now we have like a very simple thing. It has a single action. We're able to type it efficiently. It has a couple of states. We're able to type it efficiently. And as a suggested convention, you destructure the states because those are, you want to be extremely explicit about them. And you would also like export them because you want them to, like, you want to set the initial state of the reducer. So it's nice to export them. Yeah, so what's interesting here that we can do now that we're kind of exploring this pattern, is that we actually want you to be able to switch when you're in either of these states. That's something that's being informed now to, so this is being, adding the switch is informed. So when you in either of these states in the UI, you are informed that you're actually able to switch now. Secondarily, it will make sure that when you define these states, foo and bar, that you actually add the switch actions because you expect them because they should be there as a state. As you put them in your state, you say that I'm supposed to handle this action, and that's the typing actually helps you with that. And then we do this. We create a reducer, which is just transitioning these states. And what I also like about this is that we're basically going to very fundamental Redux stuff. Like you have action creators there, and you have action creators here. The only thing we enable is that we also now have this term called, I'm kind of trying to, my goal, like my big goal here is for people to embrace the ideas around state machines and finding terminology and analogies that helps you kind of move towards that. I think is beneficial. So in this case, I really love this concept of like having action creators And then you can say you have state creators. And since we have explicit states, we're actually able to say what actions are you supposed to be able to do within each state, which is something you kind of enable through this. And then you get type help for that, blah, blah, blah. Then we have use state effect. It's the same. We have our match, which allows you to, yeah, maybe we should show this. So in this matcher, you would actually like start in foo. So we're kind of, yeah, let's do this. Foo bar. Let's continue with the example above. So you start with foo, and then when you're in foo or in bar, you can do like div, make this tsx, div on click. What we'll do here, we say state, and now we actually have switch here. So we can do dispatch switch, and we can say state, just like as an example. We'll do exactly the same here. Like we could make this, yeah, maybe now I'm making a point that they are exactly the same. Which is probably not what you want to do. I'm not sure if we should highlight that in any way, but it's just an example. It just shows you how maybe we should even, yeah, okay, I'm going to do one change here. Foo bar, just to kind of emphasize that they're different. It's like a super silly example, but anyways, it's not there to be real. It's there to kind of show what's available to you. Yeah, so the point is, since we had those action creators part of our state now, where we know that when we're in foo, we're actually able to switch, and we'll dispatch that switch. And then match prop is basically foo. Yeah, no, we don't really have any property there, so let's keep some prop. So what match prop allows you to do is to, I don't care about what state I'm in, as long as that state has this property. And then it will return the state if that property exists there, which means you can use the optional chaining to use that prop, or yeah, do something else. And then we have use command effect. Yeah, so now we're into some more stuff here. Pick return types. What's it called? I state, I action, and here we also have I command actually. So it works. So we still have our switch type switch as const. And this type is actually pick return types type of actions I action. Yeah, you might argue why have the actions at the top. And for me, it's just because most of it is about the state management. So you kind of want all of that together. And you kind of, at the end, you return managing the state. So you kind of start at what comes into the reducer, and then you end with the state management. Like, again, it's just, one can choose whatever pattern. And then we have commands. It's the same concept, exactly the same concept. And then we have type command, which would be pick return types type of commands, where we expect there to be an I command. And then we have our states. And in these states, we are actually just using the log directly. So and whenever we create a foo state, we log that we moving into foo, or I guess it's moved into foo, moved into bar, and then pick types, type of states, and this should be iState. And then we have our transitions. Yeah, and we can do the same here. We can say switch actions, switch. We'll use the same pattern for that. And then we have the reducer, cool. And then initial state, there we can say foo again, in the same state. State dispatch, so we're using the use command effect here. So whenever we have a log, we'll log that message. Nice. And then we have the environment stuff, which is optional, where, what the hell? Define environment, and here it says create environment. That's wrong. This should be define environment. Here we go. So this is optional. If you haven't seen this, this basically allows you to explicitly define an environment interface for your application to interact with. So this is to avoid your application to have any kind of logic tied to the environment, meaning there shouldn't be any pointers to browser APIs, NPM packages, or anything like that. If your application needs to deal with things in the environment, it should do that through an interface that you define. And this interface can be whatever you want, but it's encouraged that it's event-based. So what you do is that you define this environment. Here I'm doing it very straightforward, like some API do something. And then you just, one event, which is like did something. And what you do is you just define the environment with the typing, and it will give you a function to create an implementation of that environment, a way to provide that environment to your application. Oh, this is old stuff. And a way to use that environment in your application. So this is completely generic and type-based. And then you go in and you actually create the environment. So this should actually be from environment interface. So that also what's nice about this is all the typing for everything that you interact with in the environment is in this environment interface folder. And then you create an environment. So in this case, I'm creating a browser environment. And this now is typed to the environment interface. So it expects me to define some API with the function do something. And if I use the event emitter of the environment, it's typed to the event, to the events I've typed in the interface. So that means that instead of this environment interface being based on functions that returns promises, it rather emits events. And that's just because that's how React prefers it. React deals very badly with promises, and there's a lot of arguments, or a lot, like I shouldn't exaggerate. There are arguments for not using promises, especially around typing, that the catch isn't typed, that it's tied to, so when you call something, it returns the promise, which means it's isolated in the component that, or in the function that, or the call site that asks for the promise, which means that even though that side effect, returning that promise, actually emits something to the environment that's interesting for other components, it's difficult to provide that information because it's only returned in the promise. But then also the promise might take longer than the life lifetime of the component, which gives an error. And yeah, so it's not really ideal. But the reason this works is because we have explicit states. So we can actually just shove whatever events we want into these reducers. And they need to be explicitly acted upon based on the state. So if this was a plain reducer, this with a plain reducer, this doesn't work that well, because you're like dispatching actions or these events directly into the reducer, and the reducer will always just perform whatever happened, which might not be what you want. But when we have explicit states, we know that whatever event or action comes in will be dealt with explicitly by the state we're in. Anyways, so this is environment interface, and then we have environments browser, and we actually called it, let's just call it environment. So we have environments where we have the actual implementations, where we have a browser environment, where we could also have a test environment, that where everything's just mocked out with just function to make it easy for you to assert that the environment was called with certain parameters. And more importantly, you have access to the event emitter, so you can simulate the environment emitting events synchronously. So that's the thing, like promises is always asynchronous, while events can be synchronous and asynchronous. So that's another argument for why promises is a challenge. When you do testing, they have to run asynchronously. But with events, you can, even though in the real world they're async, you can just fire them synchronously in a test to move the application forward, which is amazeballs. Okay, and then we have use environment, and that's also from the environment interface, where we consume that environment with the API, and the emitter is also there. So if we have a reducer who wants to deal with these events, we simply just use an effect where we subscribe to the emitter, and we just dispatch all of them into the reducer. And that means that actually any event, so you might have a pretty big environment interface, and all events in the environment interface is published on a single emitter, meaning that all reducers who subscribes to the environment will get all the events. But again, like that's the beautiful thing here, is that with the explicit states, we specifically handle the events when we want to, and if they're not handled, the reducer returns the existing state and nothing happens. So these checks is extremely cheap, and it just makes it so much simpler for you to deal with events coming from the environment. So here we have yes. So here we have a test where we have a test environment, and instead of like environment, we do create environment because it's test, right? So what we do is that we create the test environment, and here you can do whatever you want to, like mock something or whatever. And then we go in and we actually consume the hook, in this case, the switcher, and that returns a reducer. And then we get that as a component that we can just mount wherever we want. And we'll, of course, wrap it with the environment provider in this case. And here you can see what you can do. So basically what you can do here, you can go in and you can just dispatch something. So I'm not using any asynchronous stuff here. And like this one isn't really asynchronous, but you totally get the point here, because we're just dispatching a switch, and then we're checking, are we moving to bar? And then we go in and we tell the environment to emit some event, And then we can check, have you moved to a new state? So what we could do here instead, we could, for example, we could even like dispatch, and that state returns a command which calls the environment, which means that we could actually expect environment.someAPI.fetch whatever to be called. That could be a check. And then we go and check that we move to the correct state. So that's really cool. So with this pattern, there's no more async tests. There's no more mocking imports. This is exactly how you write any test. And if you, and I guess that this test is like in isolation. So it's like testing explicitly the hook, like how does the dispatching, the interaction with the environment, and all that work, which is more of a unit test. It's like leaning towards an integration test, but it really is a unit test that kind of makes sure that all the interactions with the reducer works as expected. But you could tie this into UI as well. So again, you could provide like a test environment to some UI component, like not use render reducer, but just use the render helper from React testing library or whatever it's called. And you would give your test environment and you would render some piece of UI, which might include some reducer. And then you would start like firing button clicks and stuff. But you would do exactly the same. You would expect something in the environment to be called. You can simulate events, which moves the application state forward. And again, everything's synchronous. So it's really, really, really nice. Okay, and then we have the utilities where we have T transitions. Oh my God, I have to refactor all of this. Let's just steal this. Where were we? T transitions. Cool. Yeah, so this is to extract the transitions. So this takes, this expects you to define all the transitions, like with states. And then we have T transition, and that types the object with a specific state and its handlers. So this, let's see if we can, let's see if food transitions, I guess we can do this and then do T transition instead. Oh, I state, oh, God damn it. I guess we need I state here as well. And I guess we forgot it up here as well, and probably somewhere else as well. Ah, God damn it. Use state effect, match, blah, 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 use command effect. And that has, okay, let's imagine everything's okay. So T transition allows you to, so T transitions allows you to move the transitions out of the reducer and define them separately. So you kind of reuse the same transitions object every time the reducer runs. And T transition allows you to take a specific state and define the handlers for it. So as you can see here, we have our states. And then we have food transitions. Yeah, and I should call it, and it's transitions. I want to be explicit about that. So here you can see we don't have all the transitions. We just have the food transitions. So we still give state and action, and then we choose the specific state. And this is IntelliSense, so it will help you define the correct state. And then you define that. And then I think we can do like transitions. We should really have both of them, state, action. And then you would do like foo would be foo transitions. And then bar would just be like switch to foo, for example. Something like that. So it kind of just shows you how that would work. T transitions. Cool. And then we have T emit, which just helps you. So when you define the environment interface, you like when you implement the environment interface, you want to typically like not just do it inline like I did. You want to like move a specific API into its own file, and then you want to pass the environment emitter into it. So a very typical pattern here is that you have like an index file which brings all the typing together. And the same goes for the specific environment implementation, is that you define each API in its own file. But this, yeah, okay. So I understand now why this is. So you should really import some API and some API event. Yeah. From environment interface. Yeah, so let's imagine, I guess we can kind of hint to this pattern here. So when you do the actual implementation of an environment, let's imagine this is like the browser environment. You put that in its own file. And then you create a callback, which takes the environment emitter. So you're able to type that. And then you return the correct thing. And then in the index file, that's where you kind of bring all the API together in the create environment factory. And then you'll just manually pass the emitter into each of these API factories, which typically also has other properties. Like you might have some configuration. Like if you do Firebase, you probably want to initialize Firebase in the create environment factory, and then you pass in the Firebase instance to each part of the API. Maybe you have one piece being storage of using Firebase. You might have authentication using Firebase and so on. Actually, I have an example of that in the reference apps. And then pick return types, point to a record of functions, and of state action command factories, and create a union of their return types. Yeah, it doesn't give an error anymore. Gives unknown when invalid types return. And this is super nice. Then we have pick state, which is just a way to maybe want to pass like a specific state of the reducer down to a component, and you can then make that component pick a specific state. Pick action, where would you use that? I think this is more for consistency. Yeah, I don't think you would actually use that anywhere. I haven't kind of met anywhere I've used it. But then you have pick command, which we saw in the state creators, that you would use pick command to kind of pass in a specific command that state can use. And then we have pick command state, which is basically instead of picking a specific command, you pick the states that has that command. And then we have the dev tools and use dev tools. Yeah, and I think I'm going to separate this because it just looks a bit better. Use reducer. Yeah, and let's do foo. Then we just call this switch reducer. Then we do switch. switch reducer, and then like you would destructure it like this, dispatch switch reducer, which is a nice pattern because you might want to pass the whole thing down to other components as well. And I think that's the one thing that doesn't have like a simple type yet. It's when you want to actually pass the full reducer down to another component, not only the state. And the same for the dispatch, because now you kind of have to do there isn't a type for it in TypeScript. Sorry, in React even. So you would have to do like pick state, and then the state of some reducer, and you would say like, okay, I only want this in foo, and then you would do like react.dispatch, and then the action. Like this is how you would actually have to type this in the component. Oh, if you wanted to like pass the full reducer down in a specific state, which is not like too bad at all, but it would be nice to maybe have something called, like, the thing is that this isn't called anything. Like the reducer is the function here. This isn't a reducer, so you can't really call it the reducer. There's not really a good like you maybe have to do this, like use reducer, and then yeah, like pick use reducer, something like that. Yeah, I'm not sure. So that's something to discover. Anyways, that was a nice change. Let's dump it again. Git status, git add. I guess it had also a change on the error thing. Yeah, let's publish this just to be sure. And npm publish tag next. How long have we been streaming? Oh, almost 2 hours. Yeah, and I just got a message from my partner asking me to stop streaming. But yeah, this was for me, like, if you haven't followed this stuff, it was maybe me just jumping around. But I'm really seeing this coming together now. Of course, you can always argue if it's what's a good idea, what's a bad idea, and so on. But what I'm really trying to do here is make this a very isolated tool first and foremost, so that if you have some piece of complexity in your app, which is represented by like a reducer, then you can just use this transition inside your reducer to better express the different states it's in and guard it. And then that's all you really need to do. And then you can, if you want to use like action creators with your state, you're able to do that. If you want to use commands, you're able to do that. And if you want to be very opinionated, you can even use the whole environment. So it's like the more you take on, the more kind of value it provides, and also some synergies. Talking specifically about the environment emitting events, and that you have like these explicit states in the reducers that's able to like handle those events explicitly. But yeah, so I'm pretty happy about this. I'm just looking at the refactoring we've been doing here. Like it just looks very explicit to me. I know there's a threshold of just understanding explicit states, but at least our code is a bunch of small. Oh, that I haven't done anything there. at least our code is just a bunch of small functions being very explicit, which is always a good thing. Cool. Yeah, and like looking at how this dashboard renders, it's like we'll match on the dashboard. If we're awaiting authentication, it's the skeleton. If there's an error, there's a skeleton. There should probably be an error there. If it's loading, there's a skeleton. If we're requiring authentication, we also want the skeleton. But as soon as we're loaded, we go in and we match on the current view, which is like the last one in the stack. Because there's some history here. You can like pop the stack to move backwards in views. And then if we have a dashboard, we're able to do this. If it's grocery shopping, we'll do this. And you can see I passed the full dashboard down. And these components are typed to the dashboard being in a loaded state. So they can actually consume, they know the data is there, and so on and so on. So what could be improved here, also to like optimize rendering, is that we do not just pass the dashboard down, we actually pass the full. Yeah, so that's also a tricky one. Like if you want to consume the full like reducer with the dispatcher in a specific state, you would have to, or we will have to do like this. And that's kind of not ideal. Well, maybe it's okay. The reason I'm saying this is because we're kind of passing in a new array here every time. But I do think that's perfectly fine. Yeah. I think that's perfectly fine. Yeah, also something to discover. But I'm going to actually refactor that. So we actually pass the dispatcher down so that we don't have to pass all these callbacks. We don't have to do that. Yeah, and here, like we can just pass down the full dashboard. You see it's like grabbing stuff off the dashboard anyways. So that's going to be super clean. Yeah, I think this is going to be a really great reference application. So I'm going to hopefully finish this refactor this evening, and it's already a reference in the documentation, like in the README here. You have access to family Scrum here. So I'll make sure to do that. Oh, yeah, also the resizer needs to be refactored to the latest pattern. I'll fix that as well. Anyways, thanks for following along, and I hope this has some value. But yeah, I'm excited to see it coming together. Cool. Have a great Saturday and also Sunday. And next week, I'll do some more streams with John Marco as well. Now that we have StreamYard and I can easily invite him in here. And we shouldn't have any more bad audio and stuff. I also got feedback on using YouTube playlists, so I'll check that quickly now and then see if I can kind of put episodes of the different streams I do into these playlists. Cool. Thanks again, and bye.